Are you online right now? Is anyone online? Can I just ping you quickly because I'm live streaming? I just want to make sure that you can see my big face right now. What's your email address? Or are you on Google Chat? GChat? Robin dot, like Robin dot EMAIL. Robin Murphy. Did you get my invite? Robin dot email. That's clever. I like that. I don't like a lot of things. I like that. Got it? Yeah? Once you accept, then I'll send you the link just so you can tell me if you see it. Did you accept?
I think so, yeah.
It's not allowing me to. I'm just going to email you the link.
Okay, is it waiting for people to join?
No, not a video call, just the link. All right, check to see if you got the link in your email. And see if you can join the live stream. This all makeshift. Oh my God! No, that's oh, celebrating it?
I think you just screamed that.
This is a good day.
There we go.
Good morning, everyone. How are you? How's everyone?
Good.
Good? This is good. This is good. Normally when I'm in Britain, it's like, okay, wow. Not very great. My name is Nikki Torado. I'm ecstatic to be here, and I mean that. I'm not saying it just because I'm American. I've been looking forward to this since March, since after we wrapped Redis conference in San Francisco. So this has been a long time coming for me. And I'm with a company called Rackspace. I do all their community management stuff, and that's probably the last time you hear me talk about Rackspace. But they're the one that paid the bill for me to get here, so I'm appreciative of them. This is a very different event. It's an anomaly. It's an unconferencey developer day meetup, like on steroids. So it's gonna be a whole lot better than a meetup because you're gonna be here all day with the creator of Redis and with all of you guys. And you're all really, really smart people because you're here today. And so what we wanna do is encourage you to just speak. This is a very free-flowing environment. Chill out on the bean bags, like go ahead and use the restrooms. They're right behind this wall. We've got a lot of sugar and lemonade to keep you up and awake. There's no water in the space, unfortunately, which is weird because it's the most abundant source on earth, but we'll be breaking for lunch in a little bit. But what we want to do today, what we want you guys to take away from today is a lot of knowledge. So I'm going to ask you in a second, so start thinking about what you want to take away from today because many of you flew here. So why did you get on a plane, leave your family, and come to London in October when it's cold and rainy and dark all the time? So just think about that. While you're thinking about that, we also have an unconference tomorrow. So tomorrow is going to be during the evening, more of in a meetup style, where we're going to meet more in Central London. I chose this space because I absolutely love it. I've been to a couple of events here. Despite my accent, I actually lived in London for about a year. And where you're at right now is the tech hub of London. So there's tech hub, well, actual tech hub, they actually call it that. Right down the street, there's about 3 or 4 co-working spaces around here. You're in an environment that is very rich and full of new technology and growing technology, which is what Redis is. So back to the question, what do you guys hope to get out of today? And just talk to me, throw words at me. Just so I can take notes. Does anyone want to learn or have fun?
Yeah.
Yes? Come on! I have faith in you guys to have fun. But like, what specifically, like, what are you here to talk about? Like,
Making Redis better.
better, there we go. What else?
Use it better.
Use it better. What else? There's a survey at the end, and you can tell me you hated this part, but you calculate it. Anything else? I'll give you guys time, and I'll just put up a sheet by the restroom, so when you think about it when you're going to the restroom, you're like, oh yeah, I was thinking about that when I was using the restroom. But no, seriously, we really want to make sure that you get something out of this, and secretly, we won't be able to do another one of these events if we don't have justification. So we just need to know, like, why are you guys here, and what you hope to get out of it at some point, so no pressure, but a lot of pressure. And that being said, I'm done. We're live streaming. So if you follow us, hashtag Redis London, that's where my laptop is set right there because we're live streaming. And we're also going to be recording the entire day so that you guys can play it back. If you have any questions about Wi-Fi, the information's up there, and I'll be here throughout the day if you have any questions about anything else. That being said, I'm done. Salvatore, you take over.
Thanks.
Yeah.
Hi everybody, and me here. Basically, this is the contrary of a conference. The conference is a kind of a show without content, usually. At least this is my experience. And here we want to do exactly the opposite process. To start, why we are here? We are here because we love technology, and we want to make technology. We make technology, or we make technology. And technology can be made for different reasons. And today, I believe we should stress as a reason the fact to make technology in order to have fun when we make technology and in order to solve problems. So we don't make technology. I think Redis as a community, even after 6 years, is a pretty genuine community that make technology for the technology to solve problems, so without spectacularization. And in this same way, instead of celebrating ourselves, today we should try to be very critical about what doesn't work as it should work and how we want to evolve the technology, taking risks from the point of view of trying to go towards ideas that seem very strange for the Redis community, and even to take away, to don't do what everybody believes we should do, for example. But the things are important. This is what I'm going to change starting from today compared to the past. I think that it's true that big software tend to suck. Basically, if you have this throwaway program of 20 lines of code implementing recursion or some cool quick sort, there is so much beauty inside it that you are shocked about how great it is, these 20 lines of code that can implement something very worthwhile, and every line matters, and there is no one line that's more or one that's less. It's perfect. As software grows, it starts to deteriorate more and more, and at some point it's just a big mess, and everything works because of good software engineering, but there are still beautiful parts, but the big picture is hard to maintain. So I always try to say, okay, let's take it small, and when I get some that was in the direction of making Redis too much complex, or too bloated, or too different compared to what it is today, I just say, no, stop. I don't want even to listen. I'm going to change that. In what way? I want, in general, in the future, be a project leader that allow people to end the discussion, even if at the end I will say it's a terrible idea, I will never do it. But never upfront stop of ideas. I think this is a process that after 6 years we can do, because before it was functional to the organic growth of Redis, to take it slow, to have some dogmas. But as we evolve, we need also to be able to change ourselves. Do you see what happens to technologies that are not able to change from the inside, like Memcache, for example? At some point, you no longer have the impulse that's driven the technology at the start, so there is some still energy, but then eventually it goes from there. So this is our effort. Today is very informal, so you can talk when you want. You can come here even if there was no scheduled talk for you, and say whatever you want. We can just create groups where we discuss a given idea more and more. But the general setup that I had in mind was to split the day in 2 halves. The first part in the morning, we just talk about ideas. So there is a stage where we put a lot of ideas inside the room. And then we try to make mental models of these ideas, and after lunch, with our belly much more reinforced with food, we try to discuss these ideas, to process what we created inside this room as a mass of ideas that move. And would be great if before to go away, who is willing to do so could write a few text paragraphs about what she or he captured about the event. And so if you send me these ideas, I will assemble it in a unique document so that they can have an output that people can read in the community. So that's the problem, basically. This exposing of ideas, discussion of the ideas, and creation of small pieces of text or impressions that can drive the next weeks. One important thing of this event is that 1 year ago, we did exactly 1 year ago, it worked. Worked because what was said inside this room in many ways was actually actionable and was turned into code, into documentation, into new ways of handling the community and stuff like that. So I will start to expose a few ideas that were implemented because of last year event, and other ideas are new. The ideas that I believe could be interesting, but maybe not. So I need your input in that, because it's not that everything I'm proposing today is good. It's just an idea. I will apply the same process with my ideas as well. Instead of stopping them early, I will try to see the end of the ideas, and if they are crap, I will refuse it. If they are good, I try to implement it. So let's start with the report. The first thing I did when I returned back home 1 year ago was to implement diskless replication. Diskless replication is something that many users don't feel the need, but people that deploy many Redis instances and to use. So, for example, Redis providers are probably the most interesting parties in diskless replication. It means basically that the server, the master, doesn't have to write anything on disk in order to perform the synchronization with the client. And because of diskless replication, we introduced some complexity in the replication code. And so recently, I tried to fix bugs. Redis Labs hackers fixed many bugs, and we have now a more serious implementation of diskless replication. And finally, it's probably time to remove the experimental talk. But as we finished with this side, we have the other side to do. That's diskless replication in the slave side. And Oran, that's here with us, implemented the idea of diskless replication in the slave side. It means basically that the slave loads the dataset as the master streams it directly. And this poses interesting challenges in order to enter the Redis core. But this was a great result of the yesterday meeting. Another big difference between now and 1 year ago is that Redis cluster is stable. This is very important, and I see many people in the Redis community starting to use Redis cluster. Now, for example, many messages in the mailing list are in one way or the other about Redis cluster. I believe that it is Redis cluster to throw the stone, but to hide the hand. Because we provided something that works, but not enough. Not enough tools, not enough client libraries, not enough to really make people able to use it. For example, one thing that we lack is a proxy like 12 proxy that implements Redis cluster so that people can use Redis cluster whatever the client libraries that they are using currently. Because Redis cluster clients are not rocket science, but it's very simple to write a very basic one, but the advanced features start to be more complex. For example, given that you have one slave, many slaves for different parts of the key space, it makes sense to say to the client, execute this command, but I don't need read after write consistency, so maybe pick a random slave in order to make the system more scalable, and stuff like that. And this requires some work in order to be implemented. So a proxy will be interesting, and a tool in order to perform will be interesting, and stuff like that. And we will see how important is Redis cluster for you, for the community, how many development time we should put into it. What I believe is that if we make Redis cluster great, people are Redis for different use cases compared to what they believe Redis is designed to. As people use Redis cluster for more serious projects, we will have a better Redis in the end, or an overall better Redis. Another thing that happened is that 1 year ago, Bill mentioned that he saw scalability problems when a single Sentinel monitored multiple masters. At the time, it was not clear why it happened, but then later we discovered that it was the problem was due to the fact that each logical master monitoring inside each Sentinel creates a connection to the other Sentinel. So basically, if you monitor a lot of masters, there are a lot of connections. And so this was a problem to solve. And I tried to solve it, implementing in Sentinel something that's called connection sharing. So basically, there is a single connection between each Sentinel, one in one way and another one on the other. And this connection is multiplexed by the different logical masters to monitor. This required a lot of efforts, even if it looks simple, because the design of Sentinel was totally biased towards having different logical actual sockets for logical masters. But in the end, it works, but need to get a bit more stable compared to what we have today. Because from time to time, I see users reporting crashes because there are many conditions where maybe a master is logically removed, but still there are commands pending, and there is logic to avoid problems, but still. There are more things that changed in Sentinel. One is that now we have a persistent Sentinel ID, like the Redis cluster node ID. Because before we used the Redis run ID, that's just a single random string created from scratch every time you start the server. And if there is one thing that's important in distributed system is that you have a very unique ID for each instance, so that in the case of crash recovery events, you still get correct algorithms. So this changing. And then there is invocation that you can use in order to have a cached view of the master info output. So you can perform your monitoring with additional tools using the Sentinel cached view of the master and check quorum in order to check if the Sentinel is actually able to perform the failover. It's just a testing command and stuff like that. So we have a kind of a better Sentinel. But the most important thing probably that changed in Sentinel is the documentation. We had the kind of documentation that the documentation was basically a bit driven by fear and not by the genuine attempt to make the user able to learn from the documentation. So we started saying, oh, but Sentinel has this failure mode, and this failure mode, this failure mode. And the user started to think after 2 minutes, okay, but I want to use it. Stop being sorry. And so instead now it's completely different, and Sentinel documentation starts with actual configuration examples of how you can deploy Sentinel, what are the best practices and stuff like that. One other thing that happened, okay, there was some bad thing that happened at the Redis conference last year in San Francisco, because we had a very valuable member of our community that was Matt Stancliffe, that's no longer contributing code to Redis, because we had some personal misunderstanding. It's really a shame, because as you will see today, many of the things that were done in the course of this year are thanks to Matt's efforts. But we had some basic misunderstandings, so in the end, he's no longer working at Redis. The problem is that basically, this is one example of the work that Matt did, and one example of the misunderstanding we had that culminated, ended with he leaving the project. So, Geo Indexing API was implemented by ARDB, that's a fork of Redis. Matt took this value from ARDB and put it back as an API in order to perform geo-indexing. So you have a set of points in the Earth surface, and you can ask requests like, give me all the points that are 1 kilometer and send them, and stuff like that. And it's very useful. It's very fast and works very. The problem is that this code was not ready for prime time, because it was duplicated some code from sorted sets. There was a lot of useless complexity, like there was a direction layer in order to incrementally collect replies for the client that was not needed. So this sounds strange. It was also in some way broken, because it didn't return really all the points within the radius, but there were errors. Sometimes points were not, stuff like that. So basically, Matt was frustrated because I was not merging the code. I was frustrated because it was 80% finished code. And if I had the experience that I have today after dealing with Matt, I think I will be more soft with him, because it is very valuable to get 80% work done. Okay? Now we no longer have this 80% work done. But instead we have a misunderstanding. But at the end, at least after Matt left, I wanted to celebrate his community involvement, finishing the work and merging the stuff. So I worked at his implementation and removed the duplication, speeded up the code, fixed it in a few ways, and it was removed some part of the API because it implemented JSON and things that I don't believe are really a good match inside Redis. And finally, we have Java Indexing API. And the good thing about this new API is that it's going to be basically part of Redis in very short time, because 3.2 is going to be a release candidate in 1 or 2 months or something like that. So we can start using it finally and see the applications. Okay, so basically this is the story I recounted. A few numbers about Geo IPA. It was a huge effort, because 49 commits I did in order to bring it to stable level, all these insertions and deletions. So it means that it was a lot of work for Matt to bring it, and a lot of work for ARDB to implement the geo indexing, because geo indexing works with letters, and we instead used the bits in the integer part of the sorted set score, so there was support the geo hashed idea and do a lot of work. The API is simplified, the redirection removed, and it's much more, much faster and much tested, because now what we do is to have a TCL article implementation of the same idea inside the test. And what happens is that we throw random points in the Earth's surface, and we get ranges, and Deco do the same, just brute forcing the same command, calculating the distance formula in the Earth, and we check that the set of the returning points from Redis and from the Deco implementation are the same. And this is how I discovered that the implementation was broken, actually, because this kind of fuzzy testing works very well. So, in the end, the work that Matt did was saved, and people will be very happy to use this feature inside Redis, because all the social applications have some kind of list of things that are near me. They shops, car park, sports, whatever. Transparent huge pages. Basically, this was one theory, in my opinion, because it shows that people don't care about performing deep investigations unless they really must do, like with a gun or something like that. So basically, it started with Stripe reporting that Redis had one problem because they configured the master without persistence. Then they tried to reboot the system and the data was gone. No surprise if you know Redis, but they mentioned that there were stronger properties in the replication to make sure that this would never happen. But the odd thing was that they, in the blog post, said, but no problem, Redis is crap, but we substituted it with PostgreSQL, and it's actually faster on disk. And so this was like ringing a bell, because how it's possible? Maybe I do a very bad work, but on disk, in memory, you know. So in the end, I started to check what could happen. So started to check in ABS EC2 instances what was the normal configuration for tests, and simulating a bit the tests they did. And finally, the copy on write of the process after fork happened immediately after the fork. All the pages were copied, all, if there was access instance. This happened because when transparent huge pages are enabled, the way jmalloc, that's the allocator we use, works automatically and huge pages for the memory mapped regions the allocator uses. So basically what happens is that you, with just a few accesses in the random memory of Redis, you touch all the pages in a single event loop iteration, so that the kernel has to duplicate all the address space of Redis in the forked process. And this stops the process for like 2 seconds, 5 seconds, depends on the size of memory. Usually, instead, fork should just duplicate the entry in the page table. So just the references to the page, to the memory page, not the memory page. So basically, there was nothing to fix. Basically, it was just to say, let's disable transparent huge pages. But this was a very important improvement this year, because this problem was detected by Stripe, but was actually experienced by a lot of users. But users believed it was the fork latency. But the fork latency in bare metal or in new virtualized environments, not all the Xen environments, but new systems, it's extremely small. So now finally people pay the latency like 3 milliseconds instead of 2 seconds. That's quite an improvement. But this was a sad story, because you could expect Stripe, with the scale they operate, to investigate it and provide back to the community, instead of just saying, okay, Postgres is faster, maybe some hint about what was happening. Another thing that changed is that we have more metrics, more observable Redis. And this is very important. For example, the network bandwidth tracking is important, because often the problem is not the Redis CPU, but the NICs, that are not able to cope with traffic. So we have also in the information on Gmail that in certain workloads that tend to fragment the memory is important. And we have a new plan for the memory command. I'm very excited about this command because it's like the latency command that helps you to understand and troubleshoot latency issues, but for memory. So it will give you a list of keys that are getting too fat and will provide you, for example, you can ask to the memory command, what is the bytes, the memory usage of this key exactly and stuff like that, or what are the size of the output buffers for my clients, or you can say just memory doctor, like latency doctor, and it provides a report, a human readable report of the memory usage and what can be the problem with your deployment. Since the introduction of the latency command and latency doctor, like we had one message every week in the mailing list saying, but there is a problem with latency. After this was nobody writes about it. Because people go and write latency doctor and Redis explains it in plain English. What plain English I wrote it. What's going on? So it's great. Technology that talk you with solutions. And this is going to happen with memory. Quick list is another very good contribution that we got from Matt Stanley. We talk about Matt like if died. It's just not contributing anymore, but it's fine. Initially, we considered the idea in the early days of Redis when Peter and me were doing a lot of work about lists and implemented zip lists. We said, okay, but maybe it's time to implement something more interesting in order to make a linked list of zip lists. But then we said, oh, but you get fragmentation if you remove elements in the middle. There were a lot of not funny things to deal with. Then Twitter implemented the idea and said, okay, but we just have insertions in the start of the list at the head, so we don't need to deal with fragmentation. We implement it, and we will contribute back the idea. Bye-bye, never see a line of code. But it was important because Twitter was the proof that the idea was sounding in a very big environment. So eventually, Matt did all the work, implementing it in the right way, like break the Redis past use cases in any way, with fragmentation and the fragmentation of the blobs. And so it's a lot, it uses like 10 times less memory in certain use cases, and it's much faster because also traversing the list is much faster. This is how it works. We use the linked list, so each item in the list was a single item, and now instead there are blobs that are solid pieces of memory that represent each multiple elements, and then you have a linked list of these blocks. It's a very simple idea, but works wonderfully. The problem, what was the problem? Imagine if this block here, it starts with fat and fat and fat and fat. You at some point have to split it. Or if you remove from here, you have to glue two adjacent elements together and stuff like that. So it needs some smartness, but eventually he provided a very good implementation, and quick lists allow us to discover a very good talent in the Redis community that's called the San He. Basically, it's a programmer for China that every time we commit something, read all the code. I want to imagine that he prints in A4 paper and go in the garden and read the code. Drinking beer, I don't know. Probably at the computer. And find all the bugs just in his mind analytically. It's really a great talent. And so he found problems with the quick list implementation that were fixed, and later I found other conceptual regressions because in certain use cases it was not as good as the previous list implementation, but Matic improved the implementation in order to cover these edge cases to be much faster than Redis even in these cases. And finally, I implemented RDP, persistence of quick lists as native quick lists, instead of storing them as normal lists. So at the end, the work was complete, and we merged this work, and it's also part of Redis 3.2. Another contribution from Oran from Redis Labs is the new library, the new SDS library. So basically, SDS are strings that Redis use internally, and they have a payload like normal C strings, but there is a header before the string. So we just increment the data. The problem was that even if, when you have a very small string, you have an header that is the length of the string and the available space of the string. But even if the string is 5 characters, and many strings in Redis are very small, and it's a shame. There was another problem. Because you don't want to pay even more overhead, we didn't use 64 bits fields for the length and for the available size of the string. So Redis strings were limited to 4 gigabytes. And this is very bad, because if a string, because of appending, is longer than that, you get an assertion, and Redis stops, crashes. So, actually, there were 2 goals considered to be a bit impossible to get at the same time: better memory footprint and longer strings. But fortunately, Oran implemented it in a great way. This was the old layout, so we had fixed the line available sizes, and this is the new setup. Basically, 1 byte before the string itself, there is a flex that will tell you what kind of string it is. If it's either 5, either 8, either 16, either 32, and there is also either 64 that allows us to go over the limit of 4 gigabytes. And so the fields change accordingly. This is the extreme case where actually there are no fields, because in the flag itself is stored the length of the string. So overhead is just 1 byte instead of 8 bytes. Another thing that changed is z-add. I believe we could use it as like a use case about how to improve the Redis API, because there are many commands and many data structures that we could make better options. Why is it good to add options? Because if we add commands, the list, Redis command list is already a bit intimidating, because it's very long, it's composed of strange names you can't even speak and stuff like that. Instead, options can be disclosed in a more gentle way. So, for example, you say, this is a command and its behavior is this one, but then you have 10 options that you can change the behavior of the command to make it more useful. And this was explored with z-add, adding nx, xx, ch options. And this is already useful. Another thing I would like to add is the ability to implement Markov chains in terms of sorted sets. The idea is this: if you are able to guarantee that the sum of all the scores of all the items in a sorted set is 1, so all the scores summed together is 1, I can ask the sorted set with a new operation, give me a random element based on the weight of the element, and the weight is the score. So if I have one element that's 0.5 and an element is 0.125, no, sorry, like 0.30 and 1.12 or stuff like that, the one with the higher score has more probability to be picked. And this is exactly a Markov chain. So you build the Markov chain just adding the elements with the relative score, and then you can pick the random elements in order to create Markov chains. And this can be useful in order to model prediction for the users, or to create outputs that look to be natural for different applications. But in general, we can add more options to more comments. If you have ideas for options that could enable new use cases, it's very interesting to add options. We also have a stop with count, and you can ask to get multiple elements from a set. And then there is this big feature that was created a few weeks ago. This is already part of the code, but I'm very happy about what it already does, but I'm much more excited for what it could mean in the future for Redis. What is lazy freeing of objects? Basically, it means that when you delete a large object inside Redis database, it no longer blocks. It just unlinks the item from the key space, but actually the memory is collected in a background thread at a later time. Okay? Actually, the command is not there in order to trigger this behavior, but you have to call unlink, or you can also call flushdb and flushall with an async option. So you can like completely clean your database in constant time, in just a fraction of a millisecond. And from the point of view of the semantics of Redis, the database is already empty. And you can start to write to it. But instead, there is a secondary thread that's actually performing the work in order to empty the database in the background. However, Redis can delete objects not just because the user is trying to delete it, but there are expires. There are deletes that happen because a value is overwritten, like when I write set key value. If key was an existing very big object, there is a side effect deletion that happening. And also, the slave may call flushdb before loading the RDB that the master transferred to it. So basically, there are many deletions that you can control if you want blocking or not. And there is basically an option in Redis.com in order to control each of these behaviors. So you have full control now about if you want blocking or non-blocking behavior. You may think like, but why I would ever want deletion to be blocking? The problem is that when you delete an object and you wait for it to be deleted, you are sure that the memory is reclaimed and you can add more data. When you perform it in a background thread, the semantics from the point of view of the API is the same, but the memory usage, you are not sure what is happening. The thing is that with the current implementation that's threaded, Redis is usually much faster to reclaim memory than you can allocate to new via the API. But still, there are moments where you just want blocking operations. So there is this possibility. There were two possible implementations for lazy-free. One was to incrementally, like to put objects in a lazy-free list and reclaim the memory in the event loop when we call the timer function, like to free, like we expire keys. A bit of keys incrementally in 1 second with 100 times call a function, and we incrementally release memory. And the other was the threaded approach. The threaded approach was much harder to implement, but was better. The great thing, the hard thing in order to solve was that when we have a Redis object, an element in a set, it could be referenced in another set, and it could be also in the output buffer of one or multiple clients. So how do you perform shared threaded operations on Redis values if they are shared inside the core and can be everywhere? Another problem with shared objects was the small integers. Small integers are always shared. So there was this problem to solve. And in the end, basically I changed certain things that were considered to be really an important part of the Redis core. But actually they were not. For example, the output buffer was a list of Redis objects. So you have a reference counting, you increment the reference counting. This is no longer true. In the unstable branch, it's just a linear buffer. And then there are no longer error object structures in order to implement data structures. They just use SDS strings directly. So now the data structures use a lot less memory. But especially all this enable us to work with values in different threads. So at this point, it's impossible to implement a lot of new things. Why this was never attempted in the past? Because you think, with reference counting, I have a 0 copy setup, so it's going to be much faster. Actually, the indirection in the cache put by the error object structure, because you have the key, then you have the error object structure, and then you have the value, was more of a CPU usage issue compared to copying from time to time a small piece of data. Not just that. When you send replies back to the client, you have anyway ended to copy it because you don't want to write many times. You want to write a single time all the content in the output buffer. So we used to glue different objects in a single object. Basically, this was a kind of a dogma, and we never did it, but in the end, it's going to enable a lot of things. This is what was done in the past. Let's see what we can do in the future. These are a few of the random ideas I have to add to the ones that you will provide. First, what will allow to do the object sharing that was needed for Redis will allow two things. One is to have threaded I/O, like memcache. So a single Redis instance can scale into multiple cores without sharding, and that's useful because currently, when you process a lot of operations, all the CPU time is consumed by read and write system calls. So we will have a few threads, and each thread will implement multiplexing with a pool, like it's happening now with a single thread. And this should be, because this is a tested design, because memcache is using it with much success. The access to the data structures itself is protected by a unique global lock. But this is incredibly the small work that you do when you dispatch a command. All the work is in reading the client buffers, parsing the request, and this can be parallelized in different threads. But there is one thing that's even simpler to implement and even cooler, because we never thought it was possible with Redis in a simple way. That's to process slow commands in a different threads. So now when you launch a very slow operation, like a very big intersection between sets or something like that, you have to wait and all the clients blocks. But with the new design, it will be very easy to allow these commands to be executed in other threads. How it works is pretty simple. Basically, do you know what happens currently when you have a client that blocks in a blocking operation, like a blocking list operation? There is no data. The client is put in it's blocked. When the list gets data, the client is unblocked. This behavior is captured in a file that's called blocked.c. Basically, we can use the same thing exactly in order to implement slow operations, because slow operations are marked as slow in the command table in Redis. So when they are executed, the server can block the client, take the value, and just put the key name in a list of blocked keys. Okay? Then the value and the client structure itself is sent to be processed by another thread. The thread calls the implementation of the command in a different thread, fills the client output buffer with the reply, and then returns to the main thread with the result. And the client is unblocked and processed again. So basically, for the first time, it will be able to use the multiple cores we have in modern computers in order to scale Redis slow operations. It's not just a matter of scalability, it's also a matter of latency, because currently, even if you had to launch just a single slow operation just for debugging, then all the other operations would block, and it's a shame. So we now will have better latency and better scalability implementing this. And this is threaded AO that we already talked about. And this is just what they say. Another thing that we can thread is migrate of Redis cluster, and this is the same idea exactly like slow operations. Currently, when the cluster reshuts, that we want to move some data from one master to another master, unfortunately, the way is to use the migrate command that's blocking. Migrate uses persistent connections, and the Redis data types are often already serialized in memory, so this is fast enough. But still, if we can implement non-blocking migrate in another thread in order to transfer very big objects, it's much better for Redis cluster. SSL. This is a terrible topic because it's very polarizing feature in the community. There are people that really want SSL. There are people that really tell me, why you lose time with SSL? We have more stronger needs, and SSL can be solved with VPNs or with SSL proxies and stuff like that. The problem is that people performing SSL operations at large scale have issues using proxies. Especially, this is like one problem we inherited from the fact that all the SSL proxies apparently are not great. There is no single solution that apparently works very, very well for key rotation. Should not do it. It adds complexity, or should do it in a limited way. For example, what we could do is to implement just an SSL proxy inside Redis. So when Redis starts, it like forks and implements this transparently. This is an option. Another option is to implement SSL support, but don't compile it by default. Just make it something that you can compile if you enable it in the make script. So that normally we don't pay, because Redis compiles with the minimum requirements. You just need to have libc. If you require OpenSSL, Redis is no longer the same object that can be compiled everywhere, and it's a shame. But maybe it's possible to add. The problem is there is a patch, pending patch, doesn't implement everything. But if this patch is after inspection is found to be on the Redis core that can be optionally compiled, then if it's too tight, it's better to resort to some different model, like implementing a proxy inside Redis in a different thread, but with a channel so that you can talk to the proxy via the Redis API, and you can perform scheduled key management and stuff like that.
The people that are asking for SSL, are they forwarding any use cases?
Yeah, why?
Yeah, they want to, like, over the internet or inside the data centers. Is it for authentication or just for encryption inside the data center? Or are they forwarding any use cases for this?
Yeah, one of the use cases and one of the most vocal people about this feature is Stripe. And I believe they use it internally, but because they cannot use plain text services. Because it's very sensible data and stuff like that. Of course, if you don't process payments, probably you don't have much need for it, but if not over the internet. But when you need it over the internet, you really can do with tunnels, probably.
Yeah, we're doing it over the internet. We have two data centers replicating data all the time.
That's my mistake, exactly.
Yeah, like, why would I need SSL?
And you don't have this. Even if you use an encryption and one replication, you don't have need for SSL. This is a strong point.
But the thing is that if they want the data to be protected, maybe they should protect the data. The transport should be like, you can do it at the transport level, sure, but you can also protect the data, because then you get the protection at rest. Inside the memory, inside the it's already protected. They don't have to trust you, for example. So, I don't know.
It's possible it's some kind of regular.
I believe it's a checkbox on some.
Yeah.
Yeah, it's a checkbox on PCI DSS.
Yeah, I assume that's that.
Or even if you're, the tricky thing about PCI compliance is you don't even have to be storing the actual sensitive data. If the Redis system is involved in systems that store the sensitive data, even though it never gets to Redis, it still winds up being encrypted. And I agree completely. The real solution in my mind is encrypt the data before it goes in and decrypt it and get it back out. But when you're sitting there next to the auditor, for the PCI, it's going to know. It's not SSL, it's plain text. I don't care if you encrypt it. You know, and I think that's where I.
No, I understand that point of view. For Stripe.
Yeah, basically it's something that generally we don't really want sorceries, but it makes the life to certain people much better. Sorceries to understand the number of affected people and how hard it is currently for them to actually do this currently. It's also true that Stripe is doing like a big API or stuff like that, so maybe it's like Twitter. I believe that, for example, that Twitter is going to abandon Redis in order to create their own specialized at certain scale. You basically do your stuff, so they could fix it just implementing and maintaining a fork of Redis with SSL.
But if this gets a requirement for that, the suggestion, the guy from Varnish, I don't remember the name, is launched the SSL proxy recently, and he hates SSL. So the problem is done right. So it's something to look into it, because it's tricky to get the asynchronous part with SSL done right. I remember the engine guys thought about that a lot before doing it. So that's the only suggestion.
Yeah,
and if you ever do that, you might as well use it as a separate project.
Exactly.
Speaking for
I mean, we have people who can stream out. So.
Yeah, the idea was that doing it in another thread with a Korean API was a reusable piece of work that the project could pick. And but in his blog, the Varnish author has a very detailed list of reasons why it doesn't want to implement SSL directly. But its implementation is specific for HTTP.
I don't remember the details. I saw because he was speaking about it and saying that no, we are not going to force anybody to use this. This is just our implementation of SSL proxy. But he recommended try it. If you like it, good. If you don't like it, don't like it. the type of licensing that he has. I don't know the name, but I can get it for you.
Thanks. Seamless replication. Basically, a few months ago, people from back then called 57 Signals, now it's called Basecamp, asked me, please could you check if you can make a quick patch for me, because I want to use the idea of a slave that doesn't synchronize with the master paste history, but just gets the new updates. So the slave connects and only processes the new things without caring what happened in the past. I said, yeah, yes, it's very easy thing to do because basically what you have to do just is to miss one step in the replication. I sent them the batch, and 1 week later they said, okay, we have it in production for a base camp. Okay, there was maybe some misunderstanding. It was in a stable branch, and they are running it without problems for months. So at this point they say, what about having it merged inside the Redis core? Because it works really well for us. It's like the most simple feature to misuse, because you can do horrible things with it. Because the slave can pick at any time, can for example get one set but don't get the expire, so the key materializes forever there and stuff like that. Apparently, the only place where this is useful is when you have idempotent operations, so that eventually the view of the slaves will be updated by the new write, but the write must be idempotent, so must rewrite the state of the key from scratch, otherwise it doesn't work. And also you have to have an eviction policy, because you have to make sure that keys eventually are deleted. But actually, these two requirements are what happens in most caching environments that just cache fragments of stuff, like HTML fragments caching. So it's very specific set of requirements, but it's very widespread set of requirements. And it's already implemented. Probably there will be more conflicts, more merged conflicts than lines of code, but it's possible. I want to understand if you think it's useful or not, if it's worth merging or not.
I think today they could probably use cluster for this. They will be much better served. Because what? Cluster. Because basically what they want is to have a lot of slaves for caching scalability. They don't care about the past, they care about the currency of some objects. So if you use cluster, you can replicate over thousands of servers, and each server gets a copy of the data. But
there are some use cases where you don't want to do cluster, you just want to run
apparently.
These use cases, I'm not sure that this is.
If the cluster key is the object ID, you are basically splitting the load, which is the.
Yeah, it's very limited in the number of operations that you can do with the keys. And there are some people that don't want to do it, they just want to read more. Okay, and if they want to read more, they need to run more.
The thing is that this only works like this for simple operations, because you don't have the history. So
Yes.
So for simple operations.
Apparently, what I believe is that in the case of Stripe, what they want to avoid is the synchronization with the master, because they created too much problem in the master. I believe that as a general rule, when you see that replication is broken by the slave trying to synchronize, you have to fix the operation problem that creates it. And it can be your transparent pages or slow disks or whatever. Maybe with diskless replication in the master and the slave side, we will end not really needing anymore this kind of things.
See, it is 5 times faster. 2 or 3 times faster.
It's a lot. And also there is one thing new, that with Lazy Free, now that we have non-blocking flash all, when the slave want to empty its database in order to load the new one, that was one slowness moment. It was a moment where the slave was completely blocked. We no longer have this stage, because the slave can Lazy Free the well-done data set and start loading the new one as fast as possible. You can control this in the settings if you want this behavior or the other. So with all this change in the replication, we will end with a replication that works well enough, even in with slow disk or stuff like that. That could be okay. Okay. For now, we talked about operations. Now, index. A few days ago, I published a document with ideas about how to use sorted sets, lexicographical ranges in order to create secondary indexes. However, it's always the same thing, that when we introduce a feature, for like 2 years, only 1% of people are able to use it. And then slowly the knowledge of the new feature propagates across the community, and finally people are able to use it. Also, this is probably the result of the fact it doesn't exist a Redis book that's very comprehensive about what there are a few books. One is even pretty good, but there are no books that really from scratch teach you all you can do with Redis without needing to read blogs, mailing lists, and stuff like that. But maybe in the case of indexing, we can make things simpler. We started without indexing, then sorted sets provided some form of indexing for integer ranges, for numerical ranges. And then we introduced the lexicographical ranges. Lexicographical ranges are B-tree equivalent, basically. What you can do with a B-tree, you can do with this feature. But it's hard for people to understand this because basically they have currently to implement what MySQL, for example, performs internally when indexing. So this is an example of how you can create a multi-column index using Redis B-tree capabilities. For example, you want to index all the products that are in give different rooms in a store by price. So what you do is to add items always with the same store so that they are ordered lexicographically, and you use zero padding and separators. So room 56 has an item priced 14.32, and the item object ID is 104, and so on. Then I want all the items in the room 56 that have a price between $10 and $30, okay, for example. And I use this command. However, this is complex for the average user to understand and implement. And it's also boring maybe for the skilled user to implement it this way. What we can do is to add new commands. It's not a new data structure because it uses sorted sets, but it's a new API for the same data structure. So we have one way to add one index. It takes the key, a schema description, and a set of fields, and the last field is a primary key. Then a way to delete from an index, and a way to select from an index. To select is to return items. So how we can translate the operation to add in the index? We just write edx index add my index. This is the schema, and these are the fields. What the schema means? It means integer. We can use also S to say integer float, integer string. We describe just the type of the fields. Okay. Once we have this, we can run queries. So I say edx select the schema and the fields. I just refer to the fields positionally, not by names. So we still retain the very low-level approach of Redis.
It's not SQL anymore. It's SQL.
Yeah, exactly.
You broke it.
The more SQL we can make it, the better, because people are accustomed to it. So basically, we have like an optimizer inside. We would have an optimizer that understands how to use the index, and this is especially important because now we have also an option in order to run this query in a separated thread. So it's not going to be blocking even when there is some filtering in the index. Another thing that we can do is to optimize the tables in order to make
one comment with regard to this. I think there are many use cases where you want to do sorted set, but you want the member are not unique values. And I'm not sure that all the community or all users of Redis are aware of this. So it is not actually a sorted set, it's a sorted list or whatever. So maybe it is good to have a small change to the API just to enable it. So time series is a great example for that. The values probably be the same across all the day, and you want to store it in a sorted set, so you have to add some prefix to the member.
That's possible, but
for this from the API perspective, of course, it is easy to implement.
For time series, I'm willing to explore even the approach of implementing time series as a direct data structure inside Redis with an API, because it's a very common use, but it's not well served by the data structure that implements sorted set. So it would be great to have an explicit data structure for it, in order to.
What else is limited in the sorted set for time series?
The limitation is that one is the memory, because we use the hash table in order to retrieve the score from the element that's not needed. So it's very wasteful, because time series are instead accessed never by element but by ranges. And another thing is that in sorted sets there is no API in order to see just push this element. For example, in the middle between these two symbols, whatever the score is, if we implement it as a sorted set, we can just take the score of adjacent elements and calculate a middle score in order to insert in the middle. Okay, but the problem is that if you do it multiple times, the precision of the double is no longer good to perform this, and you can no longer put elements in the middle. So basically, and also sorted set have no way to say just put this at the tail of the head. In time series, when you don't have, I would like the time series to be able to take or one indexing field like sorted set, for example, the Unix time, or just push this item and give it the next incremental ID automatically. So there are many different things that currently are not very well modeled by sorted sets. There is to understand a little bit what are the capabilities we would like to put inside time series, but I would like to have ability to put items in either sides, ability to probably automatically partition long time series over multiple keys, and other things like that. There is to understand, but I believe that would be a very worthwhile data structure to have inside Redis. We can start maybe understanding what is wrong inside sorted set for this use case, and then we can understand if it's possible to evolve sorted sets in order to better match time series use case, or it's worth or not to add a new data structure from scratch. We can also, in the other part of the day, sketch an API or something. So another feature is hash tables designed in order to be much faster, much more memory efficient compared to the past. It's like the quick list idea, but ported to hash tables. So instead of having buckets with chaining, we just have linear arrays having multiple items. It's just a matter of taking the time to implement it, and we can make most Redis datasets much more efficient, especially the ones composed of many small keys and of many entries. And we can, for example, re-implement sets in terms of this data structure and avoid to have double the representation for sets that are small, sets that are big, and have just a single representation. The problem is now a priority for the Redis community to have more memory efficiency or not, or it's better to spend time improving the API, because there is also the time trade-off. How we spend our coding time, make operations better, memory more efficient, or creating new data structure, new API, new stuff to do, like the indexing thing.
Yes. Oh.
All. Bloom filters. Bloom filters is another data structure that maybe it's not super applicable to all the problems. I believe it's one of the things that it's more easy to say it's very cool that then apply it to actual problems. But still it could be nice to have. The problem with Bloom filters is that I don't like an idea of a Redis API from Bloom filter where there are parameters. One good thing about Hyperlog logs is that they work completely abstracting you away of all the details of how it inside the working is. It's sparse, dense representation, automatically switching. You don't have to set the number of registers you want because the error is fixed at less than 1% and stuff like that. With Bloom filters, there is the same problem, but a lot harder to fix. I don't want an API where you specify the number of bits, the number of bits, the number of hash tables to use and stuff like that, because it's very complex. There is another problem. You start with a Bloom filter with a given number of entries, because today you believe it's okay, but then the number of items that the Bloom filter visits start to be greater. And then you have too much false negatives. And then you want to scale this Bloom filter. So I would like Bloom filters in the Redis implementation to be able to automatically scale. After visiting a given number of elements, to use like multiple Bloom filters or Chuko filters, or a more advanced data structure in order to make the API very simple to use. So it's a lot of work, it's interesting work. I'm not sure if it's really useful or not for most Redis users. So input very appreciated here as well. Redis cluster, we said already a few things about things that we need and multiple data set support, but it's going to be a bit more in the future probably. Another idea that we had talking with Redis Lab is a consistent cluster for Redis implemented as a proxy. So completely linearly small, very slow, and but imagine Zookeeper, much simpler to use with the Redis data structures. Could be pretty useful in certain use cases. How to implement it? Basically, the idea is that Redis CP is an external component, but shipped inside the Redis source tree that implements Raft. The client always talks with Redis CP and acts as a proxy. Redis masters just implement the state machine. So basically, all the Raft thing is implemented here, so the nodes will talk, will synchronize. The Raft log is applied as a Redis master that works as a. If the connection breaks, for example, what happens is that the Redis CP will become for a moment not available, and will replay all the log in the Redis master when it's back again, and will then rejoin the cluster again. So this could allow to have a consistent Redis experience, with strongly consistent linearizable Redis, without putting much complexity inside the object we already have. Okay. Another issue is BL Popel push with multiple lists as in. This will make sidekick more scalable. So sidekick auto asked for it multiple times for this reason. This was not performed in the past because the semantic is not obvious of what you do when there are multiple keys, because many things, many different things could happen. But I wanted to understand if there are use cases for you about blocking AirPop and push with multiple keys. And there are many other things. One thing is distance replication. On the slave side, we say 99% is done. Another is protected restarts. Protected restarts means that when you have a Sentinel Redis cluster deployment, when a master restarts, it restarts as not available, and it rejoins the class again only when it receives a slave of command in order to continue. This is useful in the case you want to perform completely diskless operations, having data safety only handled by replication. So you don't have any kind of persistence, and just you want that when a master starts, it could never happen that a slave empties itself replicating from an empty master. Okay? So the master is not available, so the failover triggers trigger, fires, and one slave becomes the new master, and the old master is unblocked on when it's configured again with the slave of the new master. This is pretty useful. Another thing is to have metadata inside the RDB file in order to be able to perform partial resynchronization after the slave restarts. And that's the most complex item that many people want. It basically means that when a slave is promoted to master, the other slaves replicating are able to perform a partial resynchronization because the slave inherits the state of the master from the point of view of the replication history. Okay, so the master represents a possible, a given history of the data set. When the slave is promoted to master, it cannot just take the same replication ID, because what could happen is that the master is just a transient failure, so the offset increments, and a slave can believe that when connecting to the new master, that the offsets are good. Instead, the slave must use a different replication ID, but must remember the master replication ID up to a given offset. So it must remember a chain of replication IDs and backlog offset. It's a bit of a complex concept, but it's useful because, for example, in Redis cluster failovers, all the new slaves will just replicate immediately from the new master. So it's useful. And then there is the idea of Redis proper users. There is a Redis document draft for this idea. Basically, you would have real users, like users as in this user can run this command and can access only this part of the key space via button and stuff like that. This is easy to implement. It's the kind of feature that enterprise really want, like mad. There is to understand if it makes sense to have this feature without authentication, without encryption, because in handshake of user credentials without.
Put it in the same proxy as this, leave us alone.
Yeah. There are many other things, but at some point I stopped because really the list of things that I have never note set of nodes with all the things that people want and that I want, but really, it was not even possible to implement all the things we said a year ago, even if new things that were not said were implemented. So
I think last time we discussed that we hear this quite, I can see quite a few templates is the combination of AOF and RDB together in the same file.
a combination
Of RDB and AOF in the same file. We discussed this last time.
at the meeting.
Improvements of the AOF rerun.
Yeah, but
I remember some design.
yeah. It was also it's not hard to do, but it never catch my attention strongly enough to sit and implement.
Yeah, I'm not sure it's so important.
So there's one aspect, there's another design idea we have for improving the AOF rewrite process. Today what you have is that the main thread keeps a history in memory of all the new commands in order to append it to the rewritten file. If we break the AOF file into multiple files, then what can happen is that instead of keeping this buffer in memory, it could just write a new file as the additional commands after the existing for the current AOF, while there's a fork process writing the new rewrite file. And then when the fork process ends, you can just use that new file as the instead of the memory buffer.
Yeah, makes sense.
That saves a lot of memory, and then maybe bundle that with the like an RDB file, and then just the continuation of the command logging.
Yeah, this could be obtained also just sending the memory copy to the other child that writes it on disk, and finally just appends to the file or something like that. But in general, the idea of second file was a very recurring idea because it also offers other advantages. For example, it's possible to write the single files in some way. Every time you see there is a deletion operation of a key, you can discard the old ones before doing the actual fork and rewrite. So this could allow to rewrite Redis AOF in certain use cases. But what was always worrying about this is that from the point of view of operations, to have a single file is logically simpler to handle, because the different files will be connected in some way by the name and should be read in sequence. And if you end with an additional file, you should never be able to change with the. I mean, if you mix multiple AOF files for an error, they should change in a very clean way. Like when a given file is written and reaches its maximum size, the next unquestionable name should be written at the end, and it's the next. So you end with a linked list of files. Basically, it solves certain problems, but makes operations a bit more complex. Now it's a very interesting abstraction to have a single file. But what Iftach was referring to, it's really a low-hanging fruit. So it's a shame to don't implement it, because we just write the AOF in terms of the RDB, and then we start to stream. It's even possible to retain the format, because we write the RDB as a fake command, like RDB with the same format and payload of the AOF. So existing tools that are able to scan the RDB file for correctness still work. So this is something I forgot to add to the slides, but probably should be one of the first things I implement when I go back home. Okay.
I have a question regarding psync with promoted slaves. Isn't it?
Sorry?
I have a question regarding psync with promoted slaves.
Yeah.
Isn't it basically draft?
No, absolutely. All these things tend to be very similar because you need basically two integers. One integer or one unguessable big string is the epoch, and one is the offset. But it's asynchronous in this case, so it's not rough. It is similar to timestamp replication. Many distributed algorithms in order to make replication more valuable has the same ideas.
Yeah. So you said the main difference is synchronicity.
Not just that, but there is no. It doesn't really create. Okay, if you the idea of the epoch and the offset, plus the fact that each Redis instance could represent a log, then you have kind of replicated machine that you try to be consistent. But the difference is that in the draft, acknowledged writes will be never discarded, so it's a lot more complex than that. Instead, what we want is just that at least failover after failover, the history is transmitted. Some continuous way to transmit the history of what happened, what is inside that. But this would require the slaves to accumulate the backlog even when they are slaves, of course. So there are a few changes needed.
This is also needed not only in failover, it's also needed when you do the balancing or when you switching between one move some slave to another node and making a master.
Yes.
Manually, not as a failover. You want to do it, you make it as a master, all of a sudden, all the slave start to.
Exactly, and especially if you have a Redis cluster set up where all the slaves are actually used for scalability, not just in order to pick up the master, then you have the problem that for some time the slaves become not available and all together, all at the same time. So it's definitely something that will be very difficult to switch with synchronous replication. But in the case you mentioned, we can do things in a simpler way because in this case the failover is controlled. For example, in this specific case, Redis cluster is able to make sure that no write is lost. Because there is a blocked in one side, when the failover process is completed, they are migrated with the redirection messages in the other side. And we could use it also in order to safely, that's a good idea actually, to safely make the new slave inherit the replication ID of the master. In this case, we can safely do that.
This is by its own, it's a good improvement.
This is
a good improvement. Forget about failover case. This is just manually rebalance cluster and stuff like this. And
exactly.
it's easier, it's faster.
At least in the case of manual failovers, this is a really very big improvement. Yeah, because you need this for rebalancing things, but you need also for upgrades, for rolling upgrades. Like you want to upgrade, all the slaves, but at some point we have to upgrade the master, so you fail over it to the new. Yeah, this is something to take note. Let's take notes. I'm thinking that also in controlled failovers, the master could even send like 1 megabyte of backlog to the slave. if we want to avoid this in case a failover will be needed, because it's completely controlled. So the master can say, okay, you are not now the new master, and here is my backlog, given legend size of backlog, just to ensure that slaves will be able to synchronize with the last few bytes. Okay, I talked already too much, so time to listen.
Is it coffee?
Yeah. So there's drinks here.
Coffee?
If you go around, there's like a little, there's mug there, and there's pedal tea.
Yes. Raising months since I saw it. Yeah, just
Yes, you going? All of them.
We talked about
Actually, I could just ask him to substitute. Nobody's listening now. How is one good? Who's it? Thursday and Friday.
maybe.
Are they taking as well?
Derek would be here. He's taking.
I came on with it.
Yeah.
But yeah, I was in France and what part of How's this?
It is.
That's why I'm not gonna put space.